where to begin. It's been at least, if I look at my videos on my page, at least 5 to 6 years that I've done a YouTube video, especially in Kubernetes. So, in some aspects I'm feeling a little bit rusty, but it's okay, right? You got to start somewhere again. So yeah, I'm back and I'm going to try and do some more episodes on Kubernetes. A lot has changed since then in the Kubernetes industry. Service meshes have been introduced. We got better monitoring tools, better integration. Kubernetes has got, even more stable in regards to the releases that it's had over time. 6 years ago, we were probably at least a 0 point something release, as now we're in the, what are we looking at right now? We are in the 1.28 latest version, as far as I know, as a release. So things have come around quite quickly in the last 6 years with Kubernetes, and I'm still diving into it day to day. And because considering I'm diving into it day to day and working on it day to day, I thought, you know what, it's my opportunity again to build some Kubernetes videos for everyone. So we're going to be doing this again. So in today's video, we're going to be looking at a service mesh for Kubernetes, and today we're going to be looking at Linkerd. And the reason why I want to look at Linkerd in particular is because recently I worked on it, built a proof of concept in a company that I work for called Trey, and there's a lot of value behind it. And also I think there's a lot of value in regards to the implementation and also for how lightweight it is. And therefore I want to kind of show that to everyone here. So enjoy the video. Cool. So in today, we're going to be looking in this area in particular, the service mesh area from the CNCF landscape. And if we kind of just go back quickly, you can see there's a whole lot of tool in there. And I remember back in the day, there wasn't this many. And today there are hundreds of different hundreds of different toolings that do pretty much similar things in different ways, with maybe some, better integration here and there, but all for particular categories, right? So in our case, we're looking at the service mesh, and there's a lot here now in regards to a lot of kind of toolings providing a service mesh. In particular, Istio and probably Linkerd are probably the top two. I'm not sure what the third one would be because I haven't really looked at it. Maybe HashiCorp Console, but in this case, we're going to be looking at Linkerd. And for all those that don't know what service mesh is, I'm not going to go too much into detail because there's lots and lots of information on the internet about a service mesh and what they do, in particular with Kubernetes. But, if I highlight this bit here in particular, Linkerd adds security, observability, and reliability to any Kubernetes cluster. 100% open source, CNCF graduated, and written in Rust. A few features that kind of stand out as part of the service mesh that Linkerd provides. We've got authorization policies, automatic mutual TLS mutual TLS authentication, automatic proxy injection, which makes it really easy to adopt a mesh inside Kubernetes. The dashboard, also quite nice to see, and I'll kind of show into that a little bit today. Distributed tracing, retries and timeouts, and maybe a bit of traffic splitting is some of the stuff that kind of stands out to me. And there's a whole lot more here that is available, as you can kind of tell. But in today's video, we're probably just going to look at some of the key areas. So like, how easy to inject the proxy into an application, but also what's it like with the dashboard experience and so on. Cool. So let's get started then, shall we? So we're going to follow the getting started guide that Linkerd provides. We're not going to be touching Helm or be touching any sort of raw manifest files to apply this stuff. We're literally just going to copy and paste a lot of the Linkerd stuff that's already provided, just to show you how quickly we can get up and running with Linkerd in a Kubernetes cluster. Now, I do have a DigitalOcean Kubernetes cluster running in the London region, which should be all hooked up if we just double check. Yep, I do. And I also have the CLI that Linkerd provides. The CLI makes it a lot easier to kind of work with Linkerd. In some aspects, for different kind of job roles, your system engineers or your cloud engineers, platform engineers, whatever they're called, might want to use this. But in some aspects, there's also another way around this with actual Kubernetes manifests themselves. So I have the Linkerd CLI installed, and I should be able to, I think, is it Linkerd? Let's just double check here. Yeah, Linkerd. So what I need to do is just copy this and modify my, need to turn off the volume, forgot about that. Oops. There's already a path here, but I can probably just export another one for now. Linkerd. Yeah, cool. Right, so we've got the Linkerd CLI set up with the terminal. So if we do Linkerd version, yeah, we've got the latest stable version of 2.14.4. And, you know, we can validate a cluster, but to be fair, we're not going to do that. We're just going to install. So the CLI has a pretty helpful kind of arguments that will be able to apply, you know, the CRDs at least, and pipe them into kubectl apply, which would then install the kind of custom resource definitions needed for Linkerd when it comes to running it. And then again, followed by Linkerd install. So if we did this, what will happen is a namespace will get created called Linkerd, along with cluster role binding, service count secrets, and so on, all the kind of things that are needed for Linkerd. Now, if we do kubectl get namespace, we can see Linkerd is there. And if we look for pods or just short PO Linkerd, you can see that they are, I don't know if I got watch, I don't, let's install that. They are initializing. Cool. So as you can see, 3 or 4, and eventually that'll be 4 or 4. Cool. So now that's done. Another feature that it does part of the CLI is it can tell you, it can validate the Linkerd settings to make sure that it's correctly set up, which, you know, at a first kind of glance when running Linkerd or installing Linkerd, it's probably a good thing to do. And, you know, over time, it's always good to check these things essentially just to make sure that, you know, our service mesh is optimal as well as working correctly. Now, if I remember correctly, there is a dashboard that we can view. So yes, we have to install the visual extension, or Viz as they call it. So let's just do that. And we're not going to check it because I think it should already be done. Viz. Yeah, cool. Web, which would be the dashboard. So everything's up and running. So what we can do is run this as a daemon, which would then pop up, and you get this really nice looking dashboard. Now, for some reason, I'm getting an internal server error, a 503, which I'm not sure why that's happening, but let's just double check that. I wonder if that is, no, be fine. Okay, cool. It's just initializing. We are good. Super. So as you can see, then you can kind of determine, well, you can already kind of gather what's meshed and what isn't meshed by just looking at this tab here in particular. So you can see 3 of 3 is meshed, 5 of 5 is meshed, but there's a lot of other stuff that isn't meshed. And, you know, we can easily mesh them up, or so many words for mesh, but yeah, you can mesh them up, right? So if we kind of go back, we're going to deploy a demo app called the emojivoto. And I think it's something that was likely built by Linkerd just to kind of give you that example of what a mesh is. An emojivoto is just kind of a random voting app with loads of emojis, you know, that essentially kind of gives you an example of what the mesh will do. So if we go and copy this, and we can close this down now, and we, oh, didn't correctly copy, and we paste. This will create a new namespace called emojivoto, along with the deployments for emojivoto, right? So emojivoto. So by default, then you'll get something like this, which let's just port forward, but 2 seconds. Let's make sure that everything's running. Yep. So if we port forward the service for the web service for emojivoto, we should be able to hit 8080. And this is what it looks like. Just a random emoji voting UI, and you can click on donut, gives you kind of like a fake 404. You can click on the laughing face and then view the leaderboard and so on. Cool. So that's that bit. And then what we can do is inject it. Now, if we look at Linkerd first, you can see emojivoto has actually appeared here. You know, it didn't really have to refresh, but I did. You can see it's not meshed up. You can see like the information is not there yet. So there's no success rate, there's no RPS, 95, 50, or 99 latency. You know, you get more information as you kind of dig into it. But if you go back to the console and you do kubectl get the deployment for emojivoto, and then you just you pipe it into Linkerd inject. What Linkerd would do is actually go and put the annotations in for the deployment to mesh it up. Now, if you look in emojivoto, you'll see that a few things are happening, right? So the old pods are terminating, but instead of 1 of 1, you're actually getting 2 of 2. And that's because Linkerd has actually added a sidecar for the proxy, which allows them kind of mesh to kind of get built up and, you know, be connected to the control plane for Linkerd. So at some point, those will terminate, and the new ones are running pretty much. So traffic technically would be going to those services. You know, and as we kind of like look here now, we can actually see emojivoto that's meshed, you know, 4.4, success rate of 91.63%. And I think that's really just simulated, just to kind of simulate the mesh itself, to show you technically what reality would look like it with some traffic. Remote request per second, P50 latency, 95, and 99 latency. So, and as you kind of go into it, you then get a graph, right? So you can see essentially, you know, what queries what. So you know that web queries voting and emoji, but the vote bot queries the web, which, you know, helps in regards to essentially understanding network calls, especially if you run, you know, an entire microservice architecture and you've got a lot of microservices. Sometimes it can be really hard to understand, you know, what request is going where. So in this aspect, you kind of get that top level, you know, high level overview, but then essentially you can also go into a deeper level aspect. And as we go forward, you kind of also get a graph as well. So you can see that Prometheus is querying emoji, web is also querying emoji. And again, you get the success rate and so on. As you go into it a bit further, then you also get live calls. So you can kind of see, you know, what's happening behind the scenes when it comes to that application. So what if someone's, you know, hitting the API? You can see here, someone from the web is essentially doing a post method on list author emoji service, and then also find by shortcode. Again, just a demo, but it's really good to know that, because in a real world scenario, in a production environment, if you have a lot of traffic, you would expect to see lots and lots and lots of requests coming through from potentially customers or even services themselves. And you'd kind of see that some of the information come through that is not meshed, as well as that it is meshed. So that's that. What's next? Let's have a look. And yeah, so that's the dashboard all set up. That's literally it to onboard a service mesh onto the cluster. Or, well, sorry, implement and integrate a service mesh into Kubernetes. The rest is kind of like up to you, right? So if you wanted to go even further, you know, we could actually go and look at some of the features here. We've already looked at, in particular, the dashboard. You know, we've looked at automatic proxy injection. In fact, have we? Let's have a look. Yeah, so we haven't, but we could do, right? So the way that Linkerd works, again, is based on annotation. So it has this inject bit. So if we look at the deployment for emojivoto and look at the web, what the Linkerd inject CLI function does is essentially it should add this annotation, linkerd.io/inject enabled. What that tells the control plane for Linkerd to do is go and add that Linkerd sidecar, as you can see here. What does that say? I had to move myself there. Oh yeah, it was ignored at first, but then it was injected. Cool. So that's it. That is pretty much implementing a service mesh, or at least implementing Linkerd into Kubernetes. I hope you found that valuable. It kind of shows how easy it is to implement Linkerd into Kubernetes. You know, if you take it into comparison with service meshes in general, You know, some can be heavyweight, some can be really lightweight. In this case, Linkerd is pretty much lightweight, right? It's pretty simple to install. Now, just for some perspectives here that you might not necessarily want to take the getting started page, or at least the getting started guide to install Linkerd. You know, in some aspects, you probably want to use Helm for code-driven aspects of deployments, or even the Kubernetes raw manifest files. And you also want to think about the CI/CD approach, right? So you probably want to deploy it via CI/CD, have some governance around it, some control mechanisms, and then also with the dashboards as well, right? You don't want to necessarily always port forward or use the CLI. You might want to put it behind an OIDC like Okta or another OIDC provider, or even behind a VPN, depending on how your company or even in general how you work as a person. So those are some things to consider. But yeah, that's it pretty much. I hope you found it valuable. I pretty much like Linkerd as a service mesh. I find it really easy. There's really not much re-architecting that needs to be done once you have a cluster. So even if you have a new cluster or an existing cluster that with loads of different services, you know, implementing a service mesh using Linkerd is pretty straightforward. And injecting the proxies, the proxy sidecars into those existing services, if you've got lots of microservices, is also pretty straightforward. And you don't always have to, you know, inject it at the deployment level. You can also inject it at the namespace level if you wanted to. So by default, anything within a particular namespace would inherit and adopt a service mesh. So yeah. Also on the other side of YouTube, you know, videos from 6 years ago, there were a lot of comments about microphone, you know, get a good microphone. And you know what? I appreciate those comments. So thank you very much, because, you know, I actually have a good microphone now. So in this video, hopefully you heard no clicking whatsoever, no background noise. All you heard was my voice. So again, to those people that messaged 6 years ago or so, or 5 years ago, I thank you very much, because I'm pretty happy with the outcome of this. And on that note, I hope you enjoyed the video, and I'll see you in the next one.